Okay, welcome back. We're here with the final video for Unit 3, Area of Study 2, Outcome 2. And today we are going to be focusing on fatigue and recovery. So this is the key knowledge points. Again, this is directly out of the study design. I encourage you to refer to this in every one of your subjects that you're doing because this is what we are going to be assessing you on. Lovely word there, the multifactorial mechanisms associated with the muscular fatigue as a result of varied exercise intensities and durations. So we want to look at what's causing us to slow down and what are the things we can do to assist in returning our body to pre-exercise levels. So talking about an active or recovery method. So we're going to look at things such as fuel depletion, metabolic byproducts, and our thermoregulation. So some really interesting stuff. And again, the key skills. So what do you need to do? What do you need to know? What do you need to be able to do? And I'll leave that there for you to have a quick flick through, or you can again refer to your own study design. I guess the key point here with this slide is the bottom dot point here. We're talking about comparing and contrasting. So when we've got the different recovery strategies, what are the similarities and differences between these methods? And again, it's another concept that's poorly understood. All right, great little table here, flow diagram to show you a few different things that are causing fatigue. So the main ones, fuel depletion. This can be, our ATP and PC runs out very quickly, but also our glycogen. We can also get a neuromuscular fatigue. So over a long period of time, the central nervous system doesn't quite send us the messages as strong as it once did. We can talk about overheating or your body temperature and how that impacts on the blood distribution around the body. We can talk about an accumulation of byproducts and what they're doing to overall performance. And then as our recovery strategies, we can talk about, replenishing our fuels. We can talk about a passive recovery, which just means go and have a seat on the sidelines and let the PC restore. Or an active recovery, which sort of means using the same muscles that you've been using and just sort of keep the blood pumping through to allow oxidation of byproducts to occur. Okay, so first thing we need to do when we're talking about fatigue and recovery is obviously work out what is fatigue. So I guess the definition that we're going to use is the inability to continue exercising at a given intensity due to our physiological, biomechanical, and or psychological factors. So again, if it just means you can't perform at the intensity that you basically started at. So from the start of a 100-meter sprint to the end of 200-meter sprints, if you're not running at the exact same speed or the top speed that you're able to achieve in that run, then you've experienced fatigue. Perfect. If you were to do 20 bench press repetitions and you did those until you couldn't lift anymore, and then you, without having an adequate rest, jumped back on and tried to do them again after a 10-second rest, and you only got 15 reps, then you've experienced fatigue. So it happens, all the time, and it's a number of factors that cause that. There's a tendency to describe muscle fatigue as a single entity, so like it's being caused by one thing, but like it says in the study design, fatigue is caused by a number of factors that are occurring at different sites around the body, so we call it multifactorial. All right, great little table here again. It's got the four main factors contributing to fatigue. So fuel depletion, the intramuscular stores of ATP and PC, and then your glycogen around your body being depleted after several hours of exercise. We've got the accumulation of hydrogen ions. Again, they're the bad guys. Don't really talk about lactic acid as much as the hydrogen ion is the harmful component of that particular molecule. Inorganic phosphates, they're hanging around once they've reattached to the ADP, and again, they're just actually getting in the way. Same with adenosine diphosphate. It's in there actually just getting in the way of reactions taking place. It sort of prevents the cross bridges from attaching and allowing the muscle to contract. And calcium ions can also build up. Neuromuscular system, there's two factors there. The messages get weaker. So if my message is weaker to my muscles, the contractions are weaker. Oh, excuse me. So that's going to be bad there. And then impaired sodium potassium gradients, which is to do with sending the message across the synaptic cleft. So if that gradient's not accurate, then you're going to lose the message strength. And of course, if you're overheating, so core temperature relates to dehydration, relates to blood flow being altered around the body, your performance is going to drop. All right, let's have a look here. Accumulation of byproducts. When blood supply to the working muscles is limited, there is an increased reliance on the anaerobic muscle metabolism to meet the energy demands of exercise. The key point here, if I'm using glycogen as a food fuel and I don't have adequate amounts of oxygen to allow for the complete breakdown of glycogen, what happens is we get an accumulation of lactic acid in our body. And as we covered in the last few slides, lactic acid splits into two, or it's made up of two things, lactate and hydrogen ions. And as I've mentioned a few times today, this is what's causing the fatigue. The accumulation of lactate and hydrogen ions occur when the rate of lactic acid, so the rate of production of lactic acid is exceeding the rate of removal. So a key point with that one is you are basically producing lactic acid right now, but there's so much oxygen being pumped around your body that you can easily cope with the small amounts of lactic acid. Once the intensity increases and there's a higher demand to move quickly, then your body can't cope at a certain point. And I guess the intensity immediately before the accumulation point, we've called this the lactate inflection point. So it represents the highest steady state workload. So if you're looking at a graph, it's just the highest sort of level point you can get before it sort of kicks up. And that's what we used to call it an inflection point. So when that inflection point is reached, due to that accumulation of hydrogen ions, the performance will be significantly reduced. I guess the key thing here is what is actually going on with this hydrogen ions? What is it doing? I think the main thing here, and I would be learning this one very well, it changes the acidity in the muscle. So what that does there is it's going to lower the overall pH, leading to an inhibition of the glycolytic enzyme. So when the enzyme is interrupted, we get it's called denaturing it, and an enzyme's job is to speed up reactions. So if that enzyme is inhibited, then the reaction of using glycogen as a fuel is going to be slower. So then, of course, performance is reduced. Now, the phosphofructokinase, I like to call that PFK, is also, sounds nice, it's also inhibited. We also get decreased calcium release from the sarcoplasmic reticulum, and that also affects that overall production of rate of the ATP. So it's reduced, muscle contraction slow, and then of course our performance is reduced. I guess the next sort of thing we can talk about is basically when we change fuels from a preferred fuel being carbohydrates at a regular exercise intensities, and when we run out of carbohydrates and we have to use fats as a fuel, it basically requires twice as much oxygen, which means that the athlete's going to slow down. So if you haven't carbohydrate loaded well, or you haven't eaten well during a race, your glycogen stores are going to be reduced, in your liver, in your muscles, and then you're going to be relying on fats. And as soon as you start relying on fats, we talk about hitting the wall, so you're going to feel not so great. You're going to slow down a lot, performance will be decreased, and that's something that's very noticeable. But it's a cause of fatigue because you're going slower than what you were at the start. And if you get to proteins, then you're going to be going very, very slowly. Okay, the next one, an interesting little point here about body heat, and people sort of sometimes don't take this as seriously as a factor of fatigue, but you've got your normal body temperature. When your muscles are contracting, we're going to create heat, so that's how we get hot when we're exercising. The way we do sort of cool down is through evaporation and sweating, so we get a bit of sweat on the body, the wind blows over it, keeps you cool, great. The other way that works is that the blood is redistributed to the surface area, to the surface closest to the skin, and again that creates a cooling effect when the air passes over that. But it plays a serious effect on reducing the amount of oxygen that's going to the working muscles. So if you've got less oxygen in now being delivered to your working muscles. Again, performance is reduced. The other one is plasma volumes. Plasma is part of your sweat. If your sweat is reduced, if your total blood volume is reduced through that plasma being lost, then your blood becomes thicker, and it's much, much harder to pump the red blood cells through that blood supply. Alright, another really good little graph here to talk about dehydration. Again, fluid intake is really important, but you've got to have electrolytes in there. Otherwise, you're not replacing what's being lost. So if you ever lick your skin after you've just been sweating, it's going to taste salty because we've got electrolytes and salts that are coming out of our body during high intensity exercise. Like I said, even at small amounts, it affects performance. So they reckon a 1% loss in body weight through sweating is a 5% decrease in performance. And those sort of small percentages are hard to detect. So they've got a little graph here that shows, like 2% of body weight loss, impaired thermoregulatory ability, get down to 4 to 6%, which isn't that much on a hot day. When you talk about how much sweating, you're going to reduce that overall strength and endurance. So go on there. Okay, the thing we need to talk about there is then what kind of techniques can we use to assist in recovery. We want to return to pre-exercise conditions as quick as possible. The quicker you can do that, the quicker you can train, the quicker you can play, the better you're going to perform. Nice little picture of the lads there in the ice bath trying to reduce swelling, edema. An active recovery is quite a good one. If you've been using the lactic acid anaerobic glycolysis system, then all you need to write for that is involving an exercise at a lower intensity once the training or the session's been completed. And we want to keep the blood pumping through the body, which means that we have a good chance to remove the things that are not supposed to be in the muscles, the byproducts. Passive recovery, so when we want to get our PC stores back, really important here, guys, because your body has to make more PC. This is a chemical fuel, not a food fuel. If I've been running and doing sprints, if I have a 30-second rest, I'm going to get 70% of that PC stores back. If I have a 3-minute rest, it's got to be passive. You've got to be sitting still. You're going to get 98% back. So pretty big, it's pretty quick to restore the PC, but you do need to wait, which is why you have a lot of interchanges in different sports. Glycogen is another one. If you don't get the glycogen stores in within the first hour of post-exercise, it can take twice as long to get your glycogen stores back to a nice full level. So really, you're seeing all the players come off the field now. Straight away, they're eating some food to ensure the glycogen levels are going to be restored as quick as possible. I sort of recommend, if you're going for a really long run, again, you might just feel like a 6-hour run tonight, to keep maintaining using glycogen as your preferred fuel, you're going to need to get 1 gram of carbohydrates or glucose per hour. So you need to consume 1 gram of carbohydrates, because you can see how much is being lost there. And if you don't do that well, then you're going to turn to fats and performance will be dropped. So yeah, as soon as possible. Same with you boys that are on the protein. Get that protein in straight away. You're going to have a much better effect in that recovery. Alright. So in class, guys, we're going to go over a lot more of these recovery strategies in a bit more detail. You'll probably fill in a couple of tables that I've made. But hopefully this is useful for your own events. You'll see a lot of players after games using an ice bath. It's not something that they would use unless they knew that there was some scientific evidence behind those sort of things working. So compression and ice baths are really there to help try and return the different metabolic byproducts away from the muscles that have been, under stress and fatigue. So give them a try, and good luck with area of study 2. Speak to your teachers, get help. Make sure you're doing everything you can do to give yourself the best chance to do well in this subject. Maybe go over your goals again, check your summary books, and don't wait till it's too late before you need help. So good job, everybody, and I'll see you next time.